Today's lesson is on measuring segments and angles. Our learning target is, let's write this out. I will define, identify, name, and label congruent segments and angles. All right, some basic vocabulary we need to talk about. First is congruent. Okay, congruent means same measure. All right, the symbol for congruent is like an equal sign with a little squiggly on top of it. Okay. All right, quick example here. If we have two segments, segment AB and segment CD, if they're congruent, that means their measures are the same. Okay, so let's say both of these have a length of 5, then I can now say that segment AB is congruent to segment CD. Okay, that would be the congruency statement. All right, also on a diagram, we want to tick mark lengths that are congruent. Okay, next we have the segment addition postulate, and we're just going to summarize this by saying if I have a segment that has two pieces, a shorter segment and a longer segment, for example, let's say the shorter segment is 2 and the longer segment is 5, that means the entire segment would be 7. And that, in a nutshell, is what the segment addition postulate lets us do. It lets us take pieces of a segment, add them together to get a total. Next, we have midpoint. A midpoint is a point that divides a segment into two congruent segments. So if I have a segment AB, and right smack dab in the middle is the midpoint M, that means that AM would be congruent with MB. M is the midpoint, cuts that segment into two congruent segments. Next we have an angle. An angle is two rays that have a common endpoint. Okay? So if I draw a ray and I draw another ray with a common endpoint, that makes an angle. Now we can name an angle a bunch of different ways. Sometimes you'll have a number in there, so we can call that angle 2. That would be the symbol for angle. Okay? An angle symbol. All right? Sometimes it has a letter or a point at the vertex. We can call it angle B. And other times, all 3 points can lead us to the name of the angle. So that we can call that angle ABC, or we can go the other way around. We can call it angle CBA. Make sure that B, the vertex of the angle, is in the middle of all of those points. All right, next we're going to classify angles. Next, we're going to talk about an acute angle. An acute angle is an angle that's less than 90 degrees. A right angle is an angle equal to 90 degrees. And an obtuse angle is an angle greater than 90 degrees, but less than 180. Okay? A 180-degree angle is called a straight angle. All right? Getting back to a right angle real quick. If we have a right angle, all right, we want to make sure that the little 90-degree mark is boxed in the corner. All right? So be aware of that. Okay, next, we're going to talk about the angle addition postulate. Is very similar to the the segment addition postulate. If I have an angle broken up into maybe 2 or 3 different angles, and let's say this angle up top is 20 degrees and the angle below it is 30 degrees. If I add them together, that's going to give me the total angle of 50 degrees. Okay, that's basically what the angle addition postulate tells us. Okay. All right. Finally, vocabulary, we have congruent angles. All right. These are angles with the same measure. So here's an example. If I have, let's say, angle A is 20 degrees, and over here, angle B is 20 degrees, then I could say that angle A is congruent to angle B because their measures are equal. All right, let's talk about some examples here. Next, we have an example about segment lengths. Okay, we have a number line with different points on it, and this first thing it's telling me to do is find the length of AB, segment AB, which is right here. So all I have to do basically is count how many spaces on the number line to get the length. So 1, 2, 3. AB is 3. Okay, and then next would be BC. BC is also 3. All right, so that completes that question. All right, the next one here is applying the segment addition postulate. If dt is 60, find the value of x, then find ds and st. So first, I'm going to add 60 to the diagram. 60 is the length of dt. All right, and using the segment addition postulate, I know that if I take ds and add that to segment st, it's going to equal the whole thing dt. So I'm just going to substitute in their expressions. ds is 2x minus 8 plus st is 3x minus 12, and they both add up to 60 as a total. So I'm going to go ahead and solve that for x. Okay, 2x and 3x gives me 5x. Negative 8, negative 12 give me negative 20. I'm going to bring that 20 over. So that gives me 5x equals 80. And divide by 5, x equals 16. Okay, so that solve for x, I've done that. Now I'm going to find the length of ds. So I'm going to take 16. I'm going to plug it in for ds here. So ds would equal 2 times 16 minus 8. And if I do that math correctly, I should get 24. And I can also plug that in over here to get st. Or I can simply take the total length, 60, and subtract 24 from it. And that should give me my other length, 36. Next we have example 3. This one says C is the midpoint of AB. So I know that midpoint will split that segment into 2 equal segments. And we're going to find all the lengths, AC, CB, and the total length of AB. So since I know AC is congruent to CB, I can set these equal to each other. So 2x plus 1 is equal to 3x minus 4. Solve that for x. So I'm going to bring the 2x over. That gives me x minus 4 over here. And 1 left over there. Add 4 to both sides. And x equals 5. And now I'm going to take that 5 and plug it in. Either one of these will give me my correct answer for everything. So I think I'm going to use this side here. So that's 2 times 5 plus 1 would be 11. So 11 is that segment. This segment I know is equal to the other segment, so that's also 11. And if I add those up, I'll get the total length, AB, which is 22. A couple more to go here. Name angle 1 in 2 other ways. Here's angle 1 right here. So I'm going to name that different way. So I'm going to go angle, and I'm going to pick the 3 points traveling around there, making sure E is in the middle. So angle AEC would be one way. And going back the other direction, angle CEA would be the other way. All right? So that's how you name angles differently. And the last example, what is the measure of angle TSW? That's this angle. If the measure of angle RST is 50, and the measure of angle RSW, which is this whole angle, is 125. So basically all I have to do is subtract these, and I can get this angle angle TSW is 75 degrees. That concludes our lesson on measuring segments and angles. I hope you understood everything, and have a nice day.